It's a pleasure to be here for the third year now at the GRIPS conference. And I think one of the really important things we can see here is what a precious resource plastic can be. Plastic is often victimised, but really plastic, whether it's compostable or whether it's not compostable, we need to look after it as a precious resource. And when it's not compostable, look after it for as long as possible. Keep it in the ecosystem as long as possible. Change the conversation. It's not cheap, it's actually valuable. And keep it going. Don't put it into the waste streams that we've been talking about. More than 100,000 tonnes, as Olivia said. So one of the things that I think we've already talked about, the global pandemic and coronavirus, but it really brought home the massive limitations that we've been having around our ultra-convenient, just-in-time global supply chains. That all came crashing down in 2020. We not only saw really shortage of essential supplies, but we also saw incredibly bad business practices. The NHS being exploited, people not getting the stuff that they need, and also the pollution and also the emissions associated with single-use plastic waste. So we decided to do something about that, and we're providing total system solutions. And one of the most important parts is not actually the products, but it's the infrastructure to support reuse. So the physical infrastructure, but also the operational infrastructure. So that's absolutely critical. And with part of the operational, we go to digital to keep everything consistent. So our mission is to displace single-use medical textiles with more effective, and that's really important for all the regulatory stuff, sustainable and economic circular alternatives, so things that can be reused again and again and again. So this issue has been going on for quite a long time. When I was a medical student over 30 years ago, when I used to scrub up, I was wearing reusables. They were cotton. At least they were reused. They got incinerated at the end, and you'd end up soaking from here down. But material science and materials have improved no end over time. We're talking about 30-year history. In the UK, for regulated medical textiles, more than 5,000 10-tonne trucks are incinerated every single year. Well, that's lining up vehicles all the way from Oxford to London along the M40, stacked up, all going into landfill. There's also the major net zero challenges. So if you look at just medical textiles on their own, that's the equivalent emissions globally of all of Finland or all of Sweden, so a country's emissions in just in medical textiles. So we decided, it seemed like the ocean, it was too big an ocean to boil really, but really something had to be done about it. So this image I really like is this plant, and there's other plants around that are pushing themselves up through the bitumen, through the oil that's baked down, and literally baked down into our society. And together we can grow up, and talking about collaboration and community, together these little trees will sprout up, creating a great ecosystem, again regenerating our world to where it needs to be. So getting on to some more of the sort of design side of things, or not just product design, this is a system engineering, and I think we talk about product and chemical design, we talk about, design is really important and critical, based from a molecular level to a whole system level. And you can see here, this is our circular economy model. We've got 3 interconnected circles. One is for reuse, one is for repurposing, and then the other, right at the bottom, is about recycling. The first one, reuse, is probably the oldest circular economy model in the world. It's when you wash your clothes. So I hope most people in here aren't big followers of fast fashion and buy something quickly, throw it in the bin. I hope you'll be washing clothes regularly. In the state of mind, you can probably tell I do. We like to also improve this reuse cycle model, because it's not just always environmentally friendly. There's heating water, there's the water generation, there's the chemicals, all those different things that are in there. And it's nice to see Richard Hickson, who's a good friend of ours as well, also being referenced previously as well. There's also a lot of innovation around repurposing. We're doing work with Nottingham Trent University, for example, taking surgical gowns, turning surgical gowns into endoscopy gowns at the end of their reuse life, taking the endoscopy down, turning it into a patient gown at the end of its reuse life, and then taking that and putting it into streetwear at the end of the year. And then, eventually, once we've repurposed as many times as we feasibly can, we go into recycling and look at some of the more advanced things like mechanical recycling, which is improving all the time. And there's no doubt plenty of presentations that you'll see over the next couple of days. So moving quickly on to a case study. This is a case study that we had with reusable masks. We're really happy to be working with HelloFace now at really addressing the not being able to see things. But this is sort of where we started, taking on a villain. So the new plastic poster child which came out, it was not only on your face, it was on the bushes, it was on the footpaths, it was everywhere. You couldn't get away from these, including around wildlife. So in the sea, in the birds' nests. Really a really strong depiction of how bad, when plastic is treated badly, it can have a negative impact on our world. So we started off with, as part of the NHS National Reuse Trial in 2020, testing across thousands of clinicians across the NHS. That then progressed rapidly in 2021 to the world's first at-scale reusable type 2R mask trial in a hospital clinical environment. So we rolled it out there. And then last year, working with NHS supply chain with RFID-enabled, fully traceable masks in the Royal Devon and Exeter Emergency Department. And not only did we track the assets, we also tracked the carbon impact and the waste impact in real time. So as they were being processed, that was tracked based off University College of London life cycle assessments. But masks, really only the tip of the iceberg. Aprons, for example, people don't think about as much, 3 times as much plastic waste during the pandemic as masks in actual weight. And then we've got surgical drapes, surgical gowns. These are things that extend beyond the pandemic, especially now we have more than 5 million people, I think it's about 7 million, on the surgical waiting lists. So these are continuing use of plastics all the time. This is some work that we did in Cornwall. So in Cornwall last year, at the birthplace of single use for medicine, which was hip joint replacement surgery or large joint replacement surgery in orthopedics, we replaced almost every single-use plastic in an operating theatre. We even used reusable packaging, as you can see here, and there was lots of innovations that we did with the teams there. But it wasn't just in orthopedics, and it wasn't just in England. We also work in Wales with colorectal surgery. This, again, another life cycle assessment from University College of London showed an 83% reduction in CO2 emissions from replacing the drapes with our reusable alternatives. Lots of innovations that you can't do as single use, such as hanging the drapes, having special hangers on there, which makes it a lot more effective as well, which I can address in the questions. But as I said early on, it's not just about the products, it's about the infrastructure to enable going forwards. So we have been developing interconnected, rapidly scalable infrastructure so we can actually process things across the country and across the globe. With that as well is workflow integration. How do you integrate into a hospital workflow? It needs to be just as seamless for the end user, so you can pick it up and use it just as you would a disposable. So I've been looking at working with local hospitals, working out what assets they've got, leveraging those assets, making sure we really go into very efficient ways. We have a partnership with the Sterile Services Department down in Cornwall, for instance, where we integrate right into their work stream. We exchange our employees, because they have a lack of employees, with the use of their sterile equipment. So it's some really nice partnerships have been forming there. So a bit more on our actual decontamination innovation. This is our zero decon pods. We can make one of these in 3 months, off-site, deploy it, have it up and running in 2 weeks. This is the one that we've actually been building recently, and I was very happy, as you can see by my very smiley face on the bottom right-hand corner, to be actually standing inside this not that long after actually conception. So we built this, deployed it on the ground, We've got a ribbon cutting event next Tuesday. We'll be delivering to theatres in June and rolling out across 4 theatres rapidly within a couple of months. So really exciting time for us. Of course, these things need to be operationalised. So we've been utilising our information technology in there and working there so we can track things, we can monitor the compliance, keep all the regulatory standards up in place, but also make that scalable through using information technologies. We've also been working on how do you capture all this value, not only the value of the cost of the product, but how do we save in the cost of carbon emissions, converting that into actual cost. How do we actually convert the real cost of waste into cost, and actually also the local return on investment, so investing things locally, all into cost structures so it's an easily understandable by the non-circular economy expert. And just quickly finishing off, 2 headlines for our 2 small business research initiative projects with Greenery NHS team. For the surgical textiles, savings have deployed across all of the NHS, £50 million per year, or 100,000 tonnes of CO2 equivalents and 25,000 tonnes of waste. So we've still got 28,000 tonnes to go in the non-surgical gowns and drapes area, and that's not including the packaging. And then finally, we have another project looking at low temperature decontamination, including the digital process to validate those. That is a whopping 230,000 tonnes of CO2 saved at not heating water. Overall, it costs 40 million to actually heat the water, so the NHS could save 20 million, and also, again, local return on investment. So I'm going to stop there, but a brief thing about talking about the work that we're doing. We're really happy we've now deployed into Kyrgyzstan and Mozambique with Médecins Sans Frontières. We're expanding out into Europe, so we're looking at not only our supply chain in the UK, but our supply chain in Europe. So it's really exciting times, and it's really great to be here again at GRIPS. Covered a lot in a short time, sorry.
Thank you, Tom. Fantastic presentation. Covered a huge amount and kept to time. Thank you very much. I guess really living the sort of circular experience there, going from the product development, deployment, but then into a facility. So there's reprocessing facilities. So a huge range of challenges there for you to take on. Looking to see if we have any hands raised for questions. A question at the back. Oh, just over there. Thank you. And we may have questions online as well.
I've got a couple of questions. First one, a more general one. So when you're going into hospitals and getting them to try the reusable things instead, are you finding any pushback from that, and what's the engagement like? 'Cause we've done a lot of work on reusable hospital things as well, and quite often it's but this is how we do it at the minute, and how do we switch to a reusable system?
Yeah, well, I think probably the most critical point here is we have not approached one hospital at all. So we only go where we're asked to go. So, and I think that's one of the big advices, only go where you're loved, because there'll be plenty of haters out there. So we don't have a sales team or a marketing team. We've had over 150 trusts approach us, and because of that approach, we get pulled in. And then, yes, we do find generally in a 1 in 10 of people going, oh, I don't like that, or I won't use that. We had actually usually anaesthetists are really quick to follow things up, but in that one in June, the anaesthetist was the one who definitely didn't want to wear our reusable gown, but all the others did. So it's very interesting. It changes, but yeah, going where you're loved really helps.
Yeah, and then on your life cycle assessment, you obviously have to assume a particular number of reuses. I'm just curious how many times you're assuming they have to be reused, and whether they actually get reused that many times. So how much loss do you get from your system from people not putting them in the right place for them to come back?
No, absolutely. I mean, in fact, the mask trial in Royal, so we assume there's 20% loss, but the mask trial in at Royal Devon and Exeter, we put out 800 masks. 200 were lost in the first day. They all took them home. They thought, these are nice. They were seen in Tesco, despite the fact it was NHS property. So we do get that. We're hoping that's going to go away, and we're going to track them and then tag them to ID cards. But yeah, no, it's a really good question. And something like the mask, it's difficult. Much easier for a surgical gown, though apparently they're quite good if you're home decorating. So yeah, so we keep following that.
Wow, thank you, Tom. So yeah, you've cracked the problem of how the NHS can come to you, and you've also developed such an attractive product that people are walking off with it, which is an unwelcome byproduct.
Yeah.
But Rich.
Just from my background coming from apparel and some of the amazing materials and manufacturing processes that are happening there, could you talk a bit about the fabrics that you're using and any kind of development plans to how the fabric itself could be more sustainable at the first instance?
Well, yeah, I mean, you talked about Reprieve, I think it was. Yeah, we love Reprieve and what they're doing. We're using polyester, and we're using polyester because it won't decompose. So there is a different place for compostables, but we're using it because it won't. It lasts a really long time. It can be a highly technical fabric, and the way the processes are coming, it's really useful. One of the issues that we're having across the whole medical device field are the fluorocarbons, or some of the forever chemicals that are used for waterproofing. We can remove it at the end of life by taking up to high alkalinity, but eventually we'd like to get rid of them completely. There's a problem because at the moment you require at least 60 Celsius to meet the compliance with the regulatory standards, and really none of the waterproofing agents last much above 50 Celsius, which is part of the reason, again, we're doing the lower temperature decontamination project, so then we can use the other chemicals such as Patagonia using for waterproofing, so then we can do so. Some really exciting material science things coming along. I've actually got a meeting in Northampton after this afternoon, talking about some of our different chemicals we use which break down in the environment, the laundry chemicals, different enzymes that can be used to digest the fats where previously they had to use high heat and bleaches. So there's a lot of exciting chemistry to do. Yeah.
Okay, thank you, Tom.